All right, so that's our introduction to, well, first of all, the reason I was outside in my pajamas is because I was showing you my spirit pajama day for Monday and my go outside day for Tuesday, all in one, because some of you are going to see this on Monday and some of you are going to see this on Tuesday. So the new lesson for today is inequalities, and so I'll write it, either as 323 or 324, depending on which class you're in. And the lesson is a review of inequalities. And then also solving inequalities, which you haven't done. Okay. So there are the things we'll be doing this time. And so first of all, let's define what inequalities are. So inequalities, or an inequality of any type, is when it basically is something that compares two things that aren't equal. Okay, so some possible things would be this symbol, which of course is less than. You could also have, so like for example, of course 4 is less than 6, something like that. You could also have is greater than. Okay, so if we said 7 is greater than 2, this would be 7 is greater than 2. Okay, this would be then, if it has a line underneath it, this means is less than or equal to. Oh, I don't have the line on that. There we go. Ooh, there we go. Okay, and then this symbol would be is greater than or equal to. So it can be both greater than, or it can also be equal to. Then there's a couple more symbols. The is not equal to, which we won't use this very much, but that's another symbol that would say things are not exactly equal. And then this symbol is approximately equal to. Calvin. Okay, oops, yeah, that doesn't really look like an equal. There we go. All right, so there's my cat's tail. Sorry about that. All right, so we might use an inequality if we were comparing things that are obviously not equal. But what we're going to really look at, this is just kind of a reminder what inequalities are. What we're really going to look at is solving inequalities. Okay. So, and basically, solving an inequality like AX is less than B is the same as solving AX equals B, except one big thing. Except, and this is the key piece here, except when you multiply or divide both sides by a negative, both sides of the inequality by a negative, you flip the symbol. Sorry about that. Flip the inequality symbol. Okay? All right. So, and why do you do that? Really quickly, if you think about it this way, so if you think about it this way, like, so if I say something like 8 is greater than 7, let's say I were to multiply both those things by a negative. So if I were to take 8 and multiply it by -1 and the 7 and multiply it by -1, okay, then I would have -8 and -7, right? But now, which is that, is -8 greater than -7? No, -8 is less than -7. So because when you multiply by a -1, it changes the orientation of how the inequalities are, or how the two terms are related. Okay, the two numbers are related. So it's a little easier to explain if I were there, but hopefully that kind of clarifies it a little bit. So you can also think of, like, if someone's in front of someone else in a line. So here's this person and here's this person, and I was going to multiply them both by a negative, then they like kind of turn around. So then they're now, if they're both multiplied by a negative, this one doesn't go as far in the other direction as this one does. Okay, I guess I should have done it in the opposite direction, but so like if it were going to go multiply this by a negative, then this one goes farther in that direction. So before this one was ahead or behind, and now they're ahead. Okay, so that's hopefully kind of explains it, but just as long as you remember that when you're solving inequalities, you flip the symbol when you solve them. That should be fine. All right, so let's do some examples of solving. Okay, so examples. Oh, by the way, note the exciting Spirit Week nail color. Very important. All right, so the first example of solving inequalities. So if you have something like 8x is greater than 32, you would do exactly the same thing as you would normally do. You divide by 8, and did I divide by a negative? No, so x is greater than 4. Done. Problem's done. Okay, so, but if I have something like this, where I have a negative, so let's say I have -3x is less than or equal to 9, okay, now when I divide by a -3, this is going to be a -3 here, but the difference is I'm now going to flip my symbol, so x is greater than or equal to -3. What is that pencil thing in there? I don't know. Let's look at another example here. So if we have something like, let's say, example 3, -1/2 x is greater than or equal to 8. That's it. Okay, so I have to multiply this by the reciprocal, which is -2/1. Okay, but then because I multiplied by a negative, I'm going to switch that symbol, and it's x is less than or equal to -16 is my solution. So that would be my answer there. Okay. We can do maybe one more example. Let's do a couple of harder examples. Let's do some examples of like kind of two-step ones here. So my fourth example here, let's do something like 2x plus 5 is less than 23. Okay, we would still subtract the 5 just like we did before. And now we subtracted the 5. So that wasn't multiplying or dividing by a negative. So that's still fine, and we can just leave that alone. So those are gone. And is less than 18. Then we're going to divide by 2. Now we did not divide by a negative, so it's just going to be x is less than 9 like that. Oops, sorry. So x is less than 9 there. Okay, but let's say we do divide by a negative. So looking at something like this. What example are we on? Example 5. So in our fifth example, let's say we do divide by a negative though. Okay, so we have 5 minus 10x is greater than 55. Okay, So we'd still do that, subtracting that first 5 off. And because we subtracted, that doesn't change the symbol. We don't flip the symbol with subtraction. So then we have a negative 10x, though, is greater than 50. Okay? So now, when we divide by that negative 10, we are going to flip that symbol because we divided by a negative. So now x is less than negative 5. Okay, let's do a couple more examples of this, and then we will be done for all the examples. And your assignment will be on Google Classroom. It's mainly just doing some IXL practice of this specific material. So, because I thought it was easier to do that than having to take a picture of your work and that sort of thing. Just practice on IXL, since the IXL practice pretty much does all of this. All right, so if you have 1/7 x minus 8 is less than or equal to 10. So you'd add that 8. In this case, we're not going to have to multiply by or divide by a negative, so it's just going to be almost as if it's the same old problem. It's just that it has less than or equal to here instead of the an equal sign. So now this one would be multiplied by 7/1, like that reciprocal like we did before. And x is less than or equal to, and this is 70 and 56, so 126. Okay. And that's your final answer for that problem. Okay, so now let's do one more example. This one is going to include both a negative and a fraction that we'll have to deal with multiplying by the reciprocal. So, and that'll be the last example, and then hopefully this will be enough for you to understand. But of course you can call or email at any time before 9 to ask questions as you need to. So this is the final example here. Negative 3/4 x, plus 7 is greater than 13. Okay? So now what we're going to do is we're going to subtract that 7. Now that does not cause us to change the symbol. So the symbol does not flip for the minus 7. So those go away. And we have negative 3/4 x and still greater than, and 13 minus 7 is 7, yeah. Okay. All right, so, 13 minus 7 is 6. Just kidding. All right, so then we're going to multiply by the reciprocal of this, but the negative, of course, because the reciprocal is negative to get rid of it. So we're going to multiply by negative 4/3. Now, because we multiplied by a negative, we do have to flip that symbol. Now, it's up to you. You can do 6 times 4. You could either do 6 times 4, which is 24, and then 24 divided by 3, which is 8. Or you could do 6 divided by 3, which is 3. And then, hang on a sec. 6 divided by 3, which is 2. Just kidding, there's my problem. And then 2 times 4, which is 8. Apparently this was not my problem this time. So then either way you're going to get 8. So x, but of course because this was a negative, it would be a negative 8. So x is less than negative 8. All right, so everyone enjoy Spirit Week. I can't wait to see all those outfits. And, did this lesson in my PJs, and not all of it outside, obviously, but hopefully you all are doing well, and hopefully you're able to at least somewhat enjoy this time with family and that sort of thing. But hopefully you also enjoy this lesson. Have a great rest of your day. Bye-bye.